Welcome to this explainer. So, you're a student stepping into clinical research for the very first time. You've probably heard all the buzz about these massive real-world data platforms like Trinex. And honestly, it is incredibly easy to just jump in, start clicking around, and see what happens. But today, we're going to bridge the gap between simply knowing how to click those buttons and having the actual foundational research literacy to ask sound clinical questions. All right, let's jump right in and tackle the biggest illusion out there for first-time researchers. Does a larger sample size fix a flawed study? It is such a tempting trap to just assume that having access to millions of electronic health records guarantees you instant, accurate science. But the answer is a resounding no. Absolutely not. A flawed query of 5 million patients simply produces a very precise, very wrong answer. The crucial takeaway here is that a massive sample size reduces random error. Sure, it makes your results look incredibly confident, but it does absolutely nothing to fix systematic bias or a fundamentally flawed study design. To make sure you get an answer that is both precise and correct, this explainer is going to be your roadmap. We'll be covering welcome to real-world data, framing your research question, dodging bias and confounding, making sense of numbers, the ethics of patient data, and building your first cohort. Okay, Section 1. Welcome to real-world data, the fundamentals of study design. When you look at the landscape of common study designs, you'll notice that real-world data studies generally sit right at the cohort study level. This means they're definitely stronger than a simple case series. But because the investigator isn't actively assigning an intervention, they lack the true randomization of a clinical trial. You really need to wrap your head around the direction of time here. Retrospective designs, they look backward. The outcome has already happened, and you are basically reconstructing the exposure from existing electronic health record data. It's fast and it's massive, but it's highly vulnerable to missing data. Prospective designs, on the other hand, look forward. You enroll patients and follow them over time. It's much better controlled, but incredibly expensive and agonizingly slow. Understanding this dichotomy is essential. Platforms like Trinex are inherently retrospective. They're amazing at efficiently finding associations in historical data, but they require really careful methodology to establish actual causation. Moving right along to framing your research question, translating ideas into queries. Listen, if you want good data out, you absolutely have to put a structured question in. Enter the PICO framework. This is a real game changer. It acts as a direct translation device to turn your clinical curiosity into actual inclusion and exclusion criteria in a cohort builder. You define your population, your intervention or exposure, your comparison group, and exactly what outcome you're measuring. Let me show you the difference in action. Asking something like, does this diabetes drug help patients, is just way too vague. It's going to produce an unbuildable or highly misleading query. A structured PICO question, however, spells everything out exactly. Like, in adults newly diagnosed with type 2 diabetes, does starting an SGLT2 inhibitor compared to a DPP4 inhibitor reduce the rate of heart failure hospitalization at 5 years? If you're a student and you can't state your research question in that structured format yet, you simply aren't ready to start building your cohort in the software. Once you've nailed down your PICO, you need to define your index event. Think of this as the starting gun for your analysis. It's the specific date that starts the clock for each patient. This brilliant little concept aligns all your patients to a shared starting line, even if their actual real-world calendar dates of treatment were literally years apart. Next up, dodging bias and confounding, the monsters in the data. And trust me, these really are the monsters lurking in your datasets. You've got selection bias, which means the network data you have just doesn't represent the general population. Misclassification bias happens when things are simply coded incorrectly in the chart. Then there's immortal time bias, where a patient is misclassified as exposed during a time they couldn't possibly even have the outcome. And channeling bias, well, this is a massive one. It happens when clinicians preferentially prescribe certain treatments based on patient health. These biases do not just average out with more patients. Channeling bias, especially, can make a perfectly good drug look falsely harmful just because it was prescribed to sicker people in the first place. So, how do we fight back against confounding variables like age, sex, or prior diseases? Platforms use a technique called propensity score matching. It basically calculates the probability of exposure based on baseline covariates and matches patients one-to-one to mimic a randomized trial. But, and this is a huge but, it only balances the variables you actually remember to include in your model. If a factor isn't recorded in the electronic health record, or you just flat out forget to select it, it remains completely unbalanced.
Okay, Section 4, Making Sense of Numbers, Epidemiologic Basics.
You've got to know the fundamental difference between incidence and prevalence. Incidence is all about the rate of new cases over time, asking how fast is this developing? Prevalence is just the proportion of a population that has a condition at a single point in time, asking how much of this is out there right now. Retrospective outcomes analysis is fundamentally calculating incidence. You are measuring what proportion of your exposed cohort develops a new outcome during your specific follow-up window. When you're evaluating those outcomes, you're going to bump into these three ratio measures all the time. A risk ratio looks at cumulative incidence between groups, an odds ratio looks at the odds of exposure, and a hazard ratio looks at the instantaneous rate of the outcome over time. Across the board, a ratio of 1.0 means absolutely no difference. A hazard ratio is specifically used for survival analysis, which is absolutely crucial when follow-up times differ between your patients. Imagine your platform spits out a hazard ratio of 0.75. Hey, a 25% risk reduction sounds amazing, right? But hold on a second. Beware the common pitfall. If the 95% confidence interval associated with that number crosses 1.0, let's say it ranges from 0.40 to 1.41, that estimate is completely imprecise. It could literally mean absolutely no effect at all. Always look beyond just the point estimate.
Almost there, the ethics of patient data, rules of engagement. You have to remember that these federated real-world networks prioritize patient privacy above literally everything else. The data stays behind institutional firewalls, meaning your results only reflect the participating health systems, not all patients everywhere. The data is strictly de-identified under HIPAA safe harbor rules. And for any students out there looking to publish, while this kind of work is often exempt from human subjects research, you must always confirm your local institutional review board policies before you proceed. Better safe than sorry.
And finally, building your first cohort, the grand finale. Let's put the whole shebang together. First up, define your exposed cohort using standardized codes. Second, define your comparison cohort. Third, you select your baseline covariates in a 1-year window right before the index event. Fourth, apply that one-to-one propensity score matching to balance those cohorts out. Fifth, define your outcome within a specific follow-up window. And finally, step 6, you interpret your results. This 6-step workflow represents the ultimate payoff. It perfectly translates your clinical PICO question into a structured, bias-adjusted query that yields trustworthy, real-world evidence. Because as we've seen in this explainer, knowing which buttons to click on a platform is the easy part. It matters far less than understanding why you are clicking them. Big data provides the incredible tools, but you have to provide the sound methodology. So for all the first-time researchers out there, what question are you going to translate next?